Chemistry time. We're going to talk about...
Did you say it?
Did you say it correctly?
We've already talked about stoichiometry.
We are going to talk about stoichiometry for the first time, I think, but if what Natalie said is correct, then we're going to talk about it.
Because we have the heart.
Yeah, the heart.
We did not videotape that, so we're going to talk about this now on video so you have it for your future reference, so that when you're studying for your test, and so that next year, when we're all in advanced chemistry, we can refer to this video to remind us of the importance of stoichiometry. The word stoichiometry, write this down, comes from the Greek word stoichios, which means element, or, I mean, it's loosely translated element. It wouldn't, and maybe it does in modern Greek, but in ancient Greek they wouldn't have known anything about these elements. But stoichios means element, and metry, you know what the suffix or the root word metry means, obviously to be what? Measured. So we're talking about the measurements of elements as they relate to one another. Stoichiometry. Say the word with me, stoichiometry. Now say it low. Stoichiometry. Stoichiometry. Say it like I said. Stoichiometry.
Stoichiometry.
Can you not do that voice?
Stoichiometry.
Sounds like I've been smoking for way too long.
Stoichiometry.
Can you really not?
Stoichiometry.
All right, we have work to do.
Somebody off of Monsters.
The most important part of stoichiometry is what specific quantity?
The heart.
The heart, which is
Small ratio.
yeah, there we go. The heart of stoichiometry.
Are we going to
Smells
bring
like
Anna
straight
Lemon
up
in again?
Please don't say that person's name in the video, Ty.
What's up, Anna Lemon?
You'll have to edit it out later.
The heart of stoichiometry is the mole ratio. What do we need to do to find the mole ratio? What is the first step?
What's it called? I'll balance it.
Yep. The equation must
Didn't
be
we just do stoichiometry?
balanced.
Yep.
Natalie. That's fine, but we're going to talk about this now on the video, as I said, for future reference.
No. Don't work.
Yeah, what we did on the bell work is stoichiometry.
That's
the
what I
first
was
step of
asking.
stoichiometry, yes. The equation must be balanced, and then all we do is the coefficients, I'm going to put another parenthesis, the coefficients from the balanced equation become a conversion factor. So effectively, stoichiometry is a special case of a conversion, a unit conversion. We're just now using this mole ratio as a conversion factor to convert from what to what? Yeah, moles of product or substance X to moles of substance Y. So basically what it allows us to do is the same stuff we did in the last chapter, except now we can change from one thing to another thing and tell the relative quantities of each that we would need. This is really important.
From a what?
Sorry, what?
Conversion factor?
Conversion factor, yep. For instance, from mole X to mole Y. And what would the ratio be? If our equation was, our balanced equation was 2x yields 3y, what would our mole ratio of X to Y be? 2 to 3, right? It's just the coefficients from the balanced equation. A good example of this is what your car, do you have a car?
Yeah.
Motor scooter?
Yep.
Lawnmower?
No.
I'm just trying to find something. Your internal combustion engine, of whatever object you own with it internally combusts, what it does, unless it's carbureted, which it kind of does then too, but the fuel injector in your car is constantly doing stoichiometry. It calculates, based on its sensors, the amount of oxygen in the air and the amount of fuel coming in through the fuel line, and it does those in a specific ratio that relates to the stoichiometry of it. So that the reaction that occurs, which causes an explosion, which is what your car moves on, is at the right stoichiometric ratio so that you don't use too much fuel or flood your engine or gas yourself out or any other problems.
I just want to know how smart these people were to like figure that out.
They're as smart as you, at least.
Probably not.
But wait, that sounded really mean. You could do this, Tyler, is what I'm trying to say. This is something
I could come up with building a whole car and the engine and everything like some old guy did.
Yeah, you could. Some old guy. He's probably long dead. He's not only old, but he's dust. But yeah, you could do that. It doesn't,
Legacy
listen, this is not the point. It is not, it's not intelligence that causes it, it's your steadfastness, that's how willing you are to stay at a problem and continue doing it. Hayes, you had a question.
So, like a turbo, how does that affect like the ratio?
A turbo, like a turbocharger in a car, is a whole different thing that works on a jet principle, which is not really the point of stoichiometry, but effectively it makes it so that you can, if I remember correctly, there's a difference between a turbocharger and a supercharger, but effectively it allows you to re-burn, like an afterburn, it lets you reuse fuel that's already been used. That might be totally wrong, look it up. I feel embarrassed having to talk about this on the video, Hayes, and now that makes me shy. Anyway, the mole ratio, this is what I do know about. The mole ratio we find from balancing the equation and using the coefficients from that balanced equation. Let's do an example. They're really not, stoichiometry problems in themselves are really not very difficult. So let's do this one together.
Okay.
Write down, the equation is going to be
Okay.
zinc plus,
Which is Z.
oh goodness, zinc, Zn, plus hydrochloric acid yields zinc chloride. Zinc plus hydrochloric acid yields zinc chloride. We'll say that the question would be,
It's me too.
no, don't do it yet because we're going to do it together. Zinc plus hydrochloric acid yields zinc chloride. This is a fine equation, but we need to have a question. Let's say we have 14.6 grams of zinc must react with how much HCl to form a perfect stoichiometric ratio. So all this is kind of just, this is just to make it actually correct. We'll talk about later limiting reactants and excess reactants and perfect stoichiometry. But for now, it's enough to, we have this question to get a given and a find. What are we given here?
14.6 grams of zinc.
Oh wait, I'm sorry, instead of saying how much, I should say with what mass. That way we can specify that we're going to a different mass. And so what am I trying to find here? So my given is 14.6 grams of zinc. What's my find?
Mass of hydrogen.
Yep, mass of hydrochloric, or hydrochloric
When you
acid.
said to perfect, what's that mean?
Yeah, we're going to get to that later. But perfect stoichiometry basically is what, like the ratio that these two things would need to have so that we use both of them up and it makes as much of this as we can without wasting either of these. We will talk about that in a future lesson. What do you mean? Oh, I don't know.
I just don't know why we're writing it down now.
Because we have to have a question. This has to be a true question. Like I can't just write 14.6 grams of zinc must react with how much hydrochloric acid, because that means nothing. So in order for it to be right, even though we don't know about this yet, they have to write this out so it's correct. Anyway, so we have a given 14.6 grams of zinc. We must find how much, what mass, of hydrochloric acid. So what should the first thing I do be? What should the first thing I be?
Write down your givens.
We all have different things to say. What's the first step of stoichiometry? We had already talked about
Balance
this.
the equation.
We have to balance the equation. So let's balance the equation. I'm just going to do it in a different color up here.
Two in front of HCl.
Oh, I'm sorry. We are missing a holding thing here. Plus H2. Oopsie daisy. There we go. Now it's right. Yeah, now it's balanced. And now, what is the mole ratio I need to find? We don't always have to write this, but just because that's what we're doing right now.
Zinc.
Zinc 2
Two
HCl.
HCl. And what is the mole ratio here?
1 to 2.
1 to 2. Good. Now, and we're going to do this together. You don't know the exact steps. You probably figure them out as we go. But the first thing we need to do is write our given. So we start with 14.6 grams of zinc. You'll remember in the last chapter, or the last couple of videos, I told you you should always write what substance it is when you write the unit. You remember my saying that? And I had even said back then, it doesn't really matter now, but when we get to the next chapter, which is now, it is going to make a difference, right? Because we're going from grams of zinc to what?
To moles.
No?
Grams of.
Grams of hydrochloric.
Grams of hydrochloric acid. So now, obviously, if we were just writing grams, this would be meaningless. But we have to specify grams of zinc to grams of hydrochloric acid. So my given is 14.6 grams of zinc. What's the first conversion I have to get? Well, I know that I need to use the mole ratio. In order to use the mole ratio, I must first convert grams to moles. So I'm going to go from grams of zinc to moles of zinc. Then I can use my mole ratio from moles of zinc to moles of hydrochloric acid. And then I'm going to go from moles of hydrochloric acid to grams of hydrochloric acid. I would encourage you, I can't enforce the way that you write these. I would encourage you two things. Always start by thinking, what am I going to get rid of and putting that on the bottom? What am I going to go to and put that on the top? But also, write in all your units before you write in any numbers. Let me repeat that. Write in all your units before you write in any numbers. Okay? Why? Well, for one thing, I think first of all, it's just the way that I do it. But also, it's going to help you. The units need to drop out. And if the units drop out, we're going to get the right answer. Secondly, when I go to check this, the first thing I'm going to check is if you have your units right. And then I'm going to check your math secondarily because I don't care quite as much about the math. So we can see that...
What's that second conversion saying?
We're going to talk about it. So I can see that my grams of zinc are going to drop out because one's here and one's on the bottom. My moles of zinc are going to drop out. My moles of hydrochloric acid are going to drop out. I'm going to be left with what? What unit am I going to be left with? Grams of hydrochloric acid, which is, you'll see, what we wanted to find. 14.6 grams of zinc must react with what mass of hydrochloric acid? This will satisfy that question. What can I put on my lines now? So,
Words, letters. In one
numbers. In 1 mole of zinc,
Oh,
how many grams of zinc, and how do you know?
Whatever it says up there.
Take out your periodic table. One person is taking out the periodic table. Let's all take out our periodic table.
65.38.
How do you know?
Because it says on the periodic table.
Do you
65.
have a mole over a mole?
Yeah, because you're going from
That's the
zinc
molar ratio
to
itself.
hydrogen.
Yep, we're going to do that in a second. And now, we're going to convert, we're going to use the mole ratio here, but we put the 1, since that was the part of the mole ratio that went with zinc, on the zinc line. We're going to put the 2, because that's the part of the mole ratio that goes with hydrochloric acid, on the hydrochloric acid line. Then,
In
for
1 gram.
in 1 mole of hydrochloric acid, how do I find how many grams are in 1 mole of hydrochloric acid?
Is it on the periodic?
I'm going to have to add them up.
Hydrogen and Cl is 35.45.
So then my total mass of hydrochloric acid in grams per mole is going to be 2, carry the 1, 3, 5, 36. 36.
Wait, what did you put hydrogen as?
1.0079?
What
No.
is the answer you got?
This says 1.0079.
Ours rounds.
That's okay. Sorry, Tyler, what did you say? Okay, so I do my add up here. That, you can do that as your first step, you can do it somewhere along the line, but make sure you show this.
Yeah,
Should
you
I,
put a heart around it.
I know, I'm going to, but should I show this? Question mark, should I show this?
Yes.
Yeah, do always show this when you have to add up. Why didn't we have to for the zinc?
Because
This
it's
is
zinc.
Just one element. But we have to when it's a non-element, so when it's a compound, we have to show that we added it up. Now, the fun and most important part, you can use it with different colors if you want. Maybe with a bonus point, use a different color. The heart, we had already written it down. The heart of the stoichiometry problem is the mole ratio. So now you draw a little heart around this, and that reminds you, it does 2 things. It makes you happy. Well, it makes me happy. And it reminds you that you have to have the mole ratio. If at any point, listen to me very carefully, Keith, if at any point you have done your stoichiometry problem and you can't have a heart because you don't have a mole ratio, you've done it wrong. Every stoichiometry problem has a mole ratio, so you must always draw the heart around it. What's the answer? How do I know? I'm going to type into my calculator, 14.6 divided by 65.38, enter, times 2, enter, times 36.532, enter, and I'm going to end up with...
Do 14.6 times 2 times 36.532.
Yeah, and the reason that works is that we can multiply, and this is what I sometimes say to do, multiply by everything on the top first, and then divide by whatever's on the bottom with an enter between each step. Either way is fine. What did you get?
I'm not doing it.
2 people need to do it, because you have to...
Times
because we have-
7
So some other person should do it too.
I guess I will do it.
Good. Do you not, the rest of you don't have calculators?
No, it's just at the bottom of it.
You're going to need to have a calculator when you do these. After we've done this problem, I'm going to turn the video off and we're going to do more practice problems, but this will be satisfactory instruction for how to do stoichiometry in general. Or it should be. You'll be able to complete the chapter U up to lesson 16.3, I believe, with this information.
16.3 grams.
16.3 grams. There's another step that we should think about. 16.3 grams, and that's the right number of sig figs, because our lowest number, we don't count the mole ratio as sig figs, it's an exact number. The ratio is exactly 2 to 1. So we got 3 sig figs from our given. So 3 sig figs in our answer, 16.3 grams. Think to yourself, does it make sense, like on a quantity scale, if I'm using about 15 grams of zinc to use about 16 grams of hydrochloric acid? Sure. What we're looking for is that if we get a number like 19,000 here, that's going to be out of bounds, right? That means we did a math there. So we're looking to make sure this is within the same kind of order of magnitude as this. Do you have questions? What was your question, Natalie? Do you have questions about how to do this?
No, but can we get a worksheet? And
Yeah, of course you can. But do you understand why? So it is a unit conversion,
Yes.
but you understand that we're converting from one substance to another, and really the only difference between what we did in the last chapter and this is that now we use this mole ratio. Do you understand where you get the mole ratio from?
Yes.
No one has any questions?
No.